Hello, this is Brian Herr with Quanta Engineering, and I wanted to share with you a 3D printed part that incorporated some product improvements. This is a mobile phone tripod mount that I had purchased off of Amazon, I think, for about $10. And what happened was, over the course of time, this piece that's in gray had broken, the original piece had. And so as I looked at it and whether I just wanted to replace it, I thought, you know what, I can just print this piece. It'd be a good, fun little project for me to do, and then I can make some improvements to it. So what I did was I noticed that the original part had some cavities on this front face. Those cavities weakened the strength of this front face because all the force from your phone being clamped, all those forces are being applied on this face, and since the columns are being restrained by the cylinders of this piece, what happens is it wants to break right here at the base and then across to where the camera is mounted. So what I did was I went in and I reinforced the bottom with some bosses. I went from the center bore or the center brass threaded insert all the way to the corner bosses, and then what I did was I reinforced the base plate with triangular gussets. Not terribly difficult, and honestly, for a 3D printed part, there's no reason this part can't just be solid from the bottom to the top. You use a little bit extra filament, but there's not a lot of benefit from having it modeled as if it's an injection molded part, as it says it's 3D printed. So the filament's relatively cheap. I think the total print cost for this was around 30 cents, something like that. So to install the threaded insert, all you do is take a heat gun or a thermal press. I used a heat gun. I threaded the insert onto a 1/4 bolt, and then I heated it up with a heat gun, and then I just pressed it in. Since the polymer itself, it melts at a pretty low temperature. I think the printer, I printed it at 200 degrees, so with a heat gun, you'll get it up to that pretty quickly. And then on the same thing on the fastener, this is just I think it's a 1032 thread. I didn't measure it, but that's the original stud that came out of the original part, and it's actually a Phillips head panhead screw. And what I did was I made the holes for both the threaded body and the head of the fastener an interference fit, and then you just get it warm enough to where you can start it, thread it in, and then as it cools, it'll shrink around the threads, and this thing does not turn freely. And so then from there, you just got to get these lined up. There's a slight lag on the camera, but once you get those started, I just got to get it going. And then from there, you just take your finger nut here, and we'll take that slider right in there, thread it on. And then the rubber pad that you see here on the paper, that rubber pad, I do have thermoplastic polyurethane filament I can print, but this is the original pad, and it snaps right in, no problem. Perfect. And so now the part, it works great. I can adjust the depth with the thumb screw, and of course, any old cell phone, you just take it and drop it in there. Works just great. So whether you do it this side or the other way. But there's no flexion, there's no bending or bowing of the plastic. And now I can prove out a design very quickly. This part takes about an hour to print, which may seem like a long time, but the reality is an hour to print a prototype is very, very quick, considering that I can spit out half a dozen different models. I can print them all either in succession, or I can print them all at the same time, and then I can test which one I like. So if you have a product that you want to see printed, or you'd like to talk about how to improve a product, let me know. Quanta Engineering, this is one of the many services that we provide. It's a simple service, but you want to print the product first, prototype it before you go to the tooling process. You'll save yourself literally tens of thousands of dollars. So have a good day.